What's happening, folks? Back for something very special, something very near and dear to my heart, and something I've had in mind to do for a little while now, certainly since I began to do watch-alongs once I got a screen recorder, and that is to do a watch-along of Carl Sagan's Cosmos, which was shot in the late 70s, and I believe in a lot of places aired on public television stations in the United States over the next couple of years, and indeed aired all the way around the world, like, over 150 countries or something ended up airing it. So yes, people who know my channel, certainly those who know my DJ mixes will be aware Carl Sagan is one of my human heroes, and I'm careful about lionizing people because inevitably people have shortcomings and personality defects or maybe inconsistencies in their work and so on. But I do think Carl Sagan is one of the very few people who is worthy of lionization, and ultimately if I had to pick a all-time human ambassador, like if we encountered alien species who were intelligent and we had to have someone, a single person, represent us, I can think of no better person than Carl Sagan. And yes, he was a NASA scientist. He also wrote journal articles and popular articles in magazines commenting on social issues and cultural issues, and he was a science popularizer, someone who tried to bridge the gap between the technical and very advanced learning that relates to a lot of scientific endeavor, but make it palatable and understandable to the public. And indeed, part of the Cosmos series is related to that and how to benefit everybody, it helps if people understand science and what it does and how it can be used to better human lives. And indeed, there's a humanistic streak which runs through the entire series. Now, this aired, as I said, in the early 80s in a lot of places. I do believe I saw a little bit of it when I was a kid, but it wasn't until I started watching the episodes in full in the, I want to say early to mid, or the mid to late 2000s, maybe like '06, '07. Certainly by '08 I had become very familiar with it. Now I have this on a DVD set, that's what we're watching here, and people who know the original Cosmos will be aware that many years later Neil deGrasse Tyson, who actually met Sagan when he was I think like a grad student, and or no, maybe it was when he was a kid. They talk about it at the beginning of the Neil deGrasse Tyson one, which is to say, many years later there was a second series of Cosmos, which was given the subtitle A Space-Time Odyssey, whereas the original one that we're about to watch is given the subtitle A Personal Voyage. But yes, Neil deGrasse Tyson did an homage and a follow-up to the Cosmos series with many of the same messages. But yes, for me, this is one of the greatest things. I remember when I first, like as an adult, watched these episodes, there were multiple times where I was weeping just from the humanistic beauty of it, and Sagan's personality, the way he expresses ideas is always very compelling. So RIP to Carl Sagan. We're going to see in the beginning, I believe, an introduction by Anne Druyan, who was the final wife of Sagan. I think he was married 2 or 3 times, but his longtime wife was Anne Druyan, who was a writer and who also became a scientist and who embarked with him on a number of adventures, the most notable of which being the creation of this series. So yeah, we're going to watch the first episode, and there's 13 episodes, so it won't be perfect one for every month. Oh, in fact it will, because this is December, and I will then do one a month until we come back around to Christmas next year, and we'll finish it on Christmas Day 2025. So yeah, it's a nice little way, a schedule that can work out. So with no further ado, let's begin a watch along of Carl Sagan's Cosmos. And as I said, if any of you know my mixes, especially like my trance mixes and my Sybient mixes, the latter of which being found in my Ambient Excursion series, you will hear so many lines over the course of this series that have been used in my mixes. And so if you're familiar with some of them, there are certain lines that may stand out to you. So here we go. Let's watch Carl Sagan's Cosmos, I believe from 1978.
Hello, my name is Anne Druyan. When Carl Sagan, Steven Soder, and I wrote the Cosmos television series in the late 1970s, a lot of things were different. Back then, the United States and the Soviet Union held the whole planet in a perpetual hostage crisis called the Cold War. The wealth and scientific ingenuity of our civilization was being squandered on a runaway arms race that employed...
Fill in your own modern commentary here. I will say I believe this follow-up was shot in the very late 90s. Sagan died in 96, and I believe this was shot a few years after that, maybe even the early 2000s. Nevertheless, it was shortly after Sagan died. And again, at that time, the Cold War had finished, and there was an idea that maybe global or at least large regional conflicts were perhaps becoming more a thing of the past. Again, fill in your own commentary for now, but just to give a little time context here, I believe she's recording this in the late 90s / very early 2000s.
More than half the world's scientists, and infested the Cold War. The wealth and scientific ingenuity of our civilization was being squandered on a runaway arms race that employed more than half the world's scientists and infested the Earth with 50,000 nuclear weapons. So much has happened since then. The Cold War is history, and science has made great strides. We've completed the spacecraft reconnaissance of the solar system, the preliminary mapping of the visible universe that surrounds us, and we have charted the universe within, the human genome. When Cosmos was first broadcast, there was no World Wide Web. It was a different world. What a tribute to Carl Sagan, a scientist who took many a punch for daring to speculate that even after 20 of the most eventful years in the history of science, Cosmos requires few revisions and indeed is rich in prophecy. Cosmos is both a history of the scientific enterprise and an attempt to convey the soaring spiritual high of its central revelation, our oneness with the universe. Now please enjoy Cosmos, the proud saga of how, through the searching of 40,000 generations of our ancestors, we have come to discover our coordinates in space and in time, and how, through the awesomely powerful method of science, we have been able to reconstruct the sweep of cosmic evolution and to find our own part in its great story.
This entire series has a wealth of great music from different composers, people from different countries, classical music as well as music like folk and international music of a more traditional nature. But Vangelis's work, I forget all the pieces. They're from a couple of his albums that he had released up to this point. But yes, Vangelis's work is very prominent in this series, including this piece, which I believe is called Heaven and Hell. So the Neil deGrasse Tyson version, he begins that much later. I think it was like late 2010s, like 2017, 2018, something like that. He began that later Cosmos series in the same spot, and he begins with an anecdote about Sagan himself. So I love the symmetry. And perhaps starting next year, maybe we'll watch the Neil deGrasse Tyson one as well. But yeah, it occurred to me as soon as they show this shot, it's like, oh right, that's where the next Cosmos series begins all those years later.
The cosmos is all that is, or ever was, or ever will be. Our contemplations of the cosmos stir us. There's a tingling in the spine, a catch in the voice, a faint sensation as if a distant memory of falling from a great height. We know we are approaching the grandest of mysteries. The size and age of the cosmos are beyond ordinary human understanding. Lost somewhere between immensity and eternity is our tiny planetary home, the Earth. For the first time, we have the power to decide the fate of our planet and ourselves. This is a time of great danger, but our species is young and curious and brave. It shows much promise. In the last few millennia, we have made the most astonishing and unexpected discoveries about the cosmos and our place within it. I believe our future depends powerfully on how well we understand this cosmos in which we float like a mote of dust in the morning sky. We're about to begin a journey through the cosmos. We'll encounter galaxies and suns and planets, life and consciousness, coming into being, evolving, and perishing. Worlds of ice and stars of diamond, atoms as massive as suns and universes smaller than atoms. But it's also a story of our own planet and the plants and animals that share it with us. And it's a story about us, how we achieved our present understanding of the cosmos, how the cosmos has shaped our evolution and our culture, and what our fate may be.
We wish to pursue the truth no matter where it leads. But to find the truth, we need imagination and skepticism both. We will not be afraid to speculate, but we will be careful to distinguish speculation from fact.
I love that. That's one of the things that I think distinguishes Sagan, is that he's not the dull, stereotypical scientist who's only concerned with empirical data and so on. He's willing to explore possibilities and hypotheticals. Excuse me. But he also is quick to distinguish between those hypotheticals and possibilities and what we can actually demonstrate through empirical data. So, yes, he's a storyteller and a scientist in equal measure.
To find the truth, we need imagination and skepticism both. We will not be afraid to speculate, but we will be careful to distinguish speculation from fact. The cosmos is full beyond measure of elegant truths, of exquisite interrelationships, of the awesome machinery of nature.
The surface of the Earth is the shore of the cosmic ocean. On this shore, we've learned most of what we know. Recently, we've waded a little way out, maybe ankle deep, and the water seems inviting. Some part of our being knows this is where we came from. We long to return. And we can't, because the cosmos is also within us. We're made of star stuff. We are a way for the cosmos to know itself. The journey for each of us begins here. We're going to explore the cosmos in a ship of the imagination, unfettered by ordinary limits on speed and size, drawn by the music of cosmic harmonies. It can take us anywhere in space and time. Perfect as a snowflake, organic as a dandelion seed, it will carry us to worlds of dreams and worlds of facts. Come with me.
Number one, great phrasing, and a lot of the things he just said will play out or be explained in more detail across the 13 episodes. But once again, anyone who knows a lot of my transmixes and Sybiont mixes, the amount of lines that he's already said which show up in those sampled sets are numerous, are manifold.
Before us is the cosmos on the grandest scale we know.
And obviously there are major and much more enhanced satellites that have been created and are now in use since the Hubble telescope. But yes, a lot of the stuff that is shown in terms of galaxies and deep space mapping comes from the work of the Hubble telescope. But of course, as I said, there are more recent ones that have done even more detailed and incredible work. So one wishes Sagan could have been alive to see some of that.
Before us is the cosmos on the grandest scale we know. We are far from the shores of Earth, in the uncharted reaches of the cosmic ocean. Strewn like sea froth on the waves of space are innumerable faint tendrils of light, some of them containing hundreds of billions of suns. These are the galaxies, drifting endlessly in the great cosmic dark. In our ship of the imagination, we are halfway to the edge of the known universe. In this, the first of our cosmic voyages, we begin to explore the universe revealed by science. Our course will eventually carry us to a far-off and exotic world, but from the depths of space, we cannot detect even the cluster of galaxies in which our Milky Way is embedded, much less the Sun or the Earth. We are in the realm of the galaxies, 8 billion light years from home. No matter where we travel, the patterns of nature are the same as in the form of this spiral galaxy. The same laws of physics apply everywhere, throughout the cosmos. But we have just begun to understand these laws. The universe is rich in mystery. Near the center of a cluster of galaxies, there's sometimes a rogue elliptical galaxy made of 1 trillion suns, which devours its neighbors. Perhaps this cyclone of stars is what astronomers on Earth call a quasar.
And we do know that quasars are essentially active galactic nuclei, as they're now called, which is to say very dense, compact, and extremely bright regions of some of the biggest galaxies that shoot out relativistic jets from their massive, supermassive black holes at the center. So again, some of the terminology for the things that he's referring to, and indeed much of the understanding, has evolved since the day of this original broadcast in the late 70s. But as Andrian said, a lot of the things he talks about here are still not only the consensus understanding, but some of his discussions of the concepts are quite on target for being as early as the series was, given that we now have instruments that can give us even more detail about galactic, early galaxies and galactic forms more generally. So shout out to Carl Sagan once again.
Our ordinary measures of distance fail us here in the realm of the galaxies. We need a much larger unit, the light year. It measures how far light travels in a year, nearly 10 trillion kilometers. It measures not time, but enormous distances.
The track that's starting here, it's like La Création du Monde, or The Creation of the World. It's a Vangelis track, and it's maybe my favorite in this entire series. Again, the whole series is full of great music, but this one in particular always gives me the goosebumps.
Light year. It measures how far light travels in a year, nearly 10 trillion kilometers. It measures not time, but enormous distances. In the Hercules cluster, the individual galaxies are about 300,000 light years apart. So light takes about 300,000 years to go from one galaxy to another. Like stars and planets and people, galaxies are born, live, and die. They may all experience a tumultuous adolescence. During their first 100 million years, their cores may explode, seen in radio light. Great jets of energy pour out and echo across the cosmos. Worlds near the core or along the jets would be incinerated. I wonder how many planets and how many civilizations might be destroyed. In the Pegasus cluster, there's a ring galaxy, the wreckage left from the collision of two galaxies, a splash in the cosmic pond. Individual galaxies may
The number of mixed titles that I've already heard, which again is just my penchant long time for sampling Sagan, but Tendrils of Light, A Splash in the Cosmic Pond, these are all mixed titles that I've recorded, and I think most of which are up on YouTube over the years. So as I watch this, it's hard to like separate my own personal involvement with using these lines, which, you know, as a DJ has been one of the most gratifying things to think that, you know, a lot of people who've downloaded my mixes from various places, who have watched them on YouTube, you know, maybe bookmark them in their browsers. They are good music from great producers, but they also continue to champion the messages of Cosmos, and will do so, hopefully, long after I've gone the way of a extinguished galaxy.
ring galaxy, the wreckage left from the collision of two galaxies, a splash in the cosmic pond. Individual galaxies may explode and collide, and their constituent stars may blow up as well. In this supernova explosion, a single star outshines the rest of its galaxy. We are approaching what astronomers on Earth call the local group. 3 million light years across, it contains some 20 galaxies. It's a sparse and rather typical chain of islands in the immense cosmic ocean. We are now only 2 million light years from home. On the maps of space, this galaxy is called M31, the Great Galaxy in Andromeda. It's a vast storm of stars and gas and dust. As we pass over it, we see one of its small satellite galaxies. Clusters of galaxies and the stars of individual galaxies are all held together by gravity. Surrounding M31 are hundreds of globular star clusters. We're approaching one of them. Each cluster orbits the massive center of the galaxy. Some contain up to 1 million separate stars. Every globular cluster is like a swarm of bees bound by gravity, every bee a sun. From the Pegasus cluster, our voyage has taken us 200 million light years to the local group, dominated by two great spiral galaxies. Beyond M31 is another very similar galaxy, its spiral arms slowly turning once every 250 million years. This is our own Milky Way, seen from the outside. This is the home galaxy of the human species. In the obscure backwaters of the Carina Cygnus spiral arm, we humans have evolved to consciousness and some measure of understanding. Concentrated in its brilliant core and strewn along its spiral arms are 400 billion suns. It takes light 100,000 years to travel from one end of the galaxy to the other. Within this galaxy are stars and worlds, and, it may be, an enormous diversity of living things and intelligent beings and spacefaring civilizations. Scattered among the stars of the Milky Way are supernova remnants, each one the remains of a colossal stellar explosion. These filaments of glowing gas are the outer layers of a star which has recently destroyed itself. The gas is unraveling, returning star stuff back into space. And at its heart are the remains of the original star, a dense, shrunken stellar fragment called a pulsar, a natural lighthouse, blinking and hissing, a sun that spins twice each second. Pulsars keep such perfect time that the first one discovered was thought to be a sign of extraterrestrial intelligence, perhaps a navigational beacon for great ships that travel across the light years and between the stars. There may be such intelligences and such starships, but pulsars are not their signature. Instead, they are the doleful reminders that nothing lasts forever, that stars also die. We continue to plummet, falling thousands of light years towards the plane of the galaxy. This is the Milky Way, our galaxy seen edge on, billions of nuclear furnaces converting matter into starlight. Some stars are flimsy as a soap bubble. Others are 100 trillion times denser than lead. The hottest stars are destined to die young, but red giants are mostly elderly. Such stars are unlikely to have inhabited planets. But yellow dwarf stars, like the sun, are middle-aged, and they are far more common. These stars may have planetary systems, and on such planets, for the first time in our cosmic voyage, we encounter rare forms of matter: ice and rock, air and liquid water. Close to this yellow star is a small, warm, cloudy world with continents and oceans. These conditions permit an even more precious form of matter to arise: life. But this is not the Earth.
So again, when I do these watch-alongs, I'm often commenting on cinematography or the writing, or depending on what it is, a joke or some of the dialogue. But when it comes to these Sagan watch-alongs or Cosmos watch-alongs, there probably will be long sections where I'm just enjoying it, and I haven't seen this for a few years, so even though of course I know the series very well, there's moments where I'm just luxuriating in the nostalgia and remembering the different sections. So yeah, obviously I'm going to be a little quieter in these watch-alongs, but I hope you're enjoying. And as I said, we're just at the beginning, and as Sagan said, we're just at the beginning of the shores of the cosmic ocean.
Intelligent beings have evolved and reworked this planetary surface in a massive engineering enterprise. In the Milky Way galaxy, there may be many worlds on which matter has grown to consciousness. I wonder, are they very different from us? What do they look like? What are their politics, technology, music, religion? Or do they have patterns of culture we can't begin to imagine? Are they also a danger to themselves. Among the many glowing clouds of interstellar gas is one called the Orion Nebula, only 1,500 light-years from Earth. These three bright stars are seen by Earthlings as the belt in the familiar constellation of Orion the Hunter. The nebula appears from Earth as a patch of light, the middle star in Orion's sword. But it is not a star. It is another thing entirely, a cloud that veils one of nature's secret places. This is a stellar nursery, a place where stars are born. They condense by gravity from gas and dust until their temperatures become so high that they begin to shine. Such clouds mark the births of stars, as others bear witness to their deaths. And after stars condense in the hidden interiors of interstellar clouds, what happens to them? The Pleiades are a loose cluster of young stars only 50 million years old. These fledgling stars are just being let out into the galaxy, still surrounded by wisps of nebulosity, the gas and dust from which they formed.
There's a great psytrance duo, also known as Ethnica, but who have gone in many releases under the name the Pleiadians, and they ultimately, clearly, are fans of space exploration and perhaps cosmos itself. So yeah, shout out to Ethnica, aka the Pleiadians.
There are clouds that hang like ink blots between the stars. They are made of fine rocky dust, organic matter, and ice. Inside, a few stars begin to turn on. Nearby worlds of ice evaporate and form long comet-like tails, driven back by the stellar winds. Black clouds, light years across, drift between the stars. They're filled with organic molecules. The building blocks of life are everywhere. They're easily made. On how many worlds have such complex molecules assembled themselves into patterns we would call alive? Most stars belong to systems of 2 or 3 or many suns, bound together by gravity. Each system is isolated from its neighbors by the light years. We are approaching a single ordinary yellow dwarf star, surrounded by a system of 9 planets, dozens of moons, thousands of asteroids,
And as many of you will know, the solar system is now regarded as having 8 regular planets, or I forget the technical term, like major planets. Pluto has since been downgraded to a dwarf planet, and indeed, it's actually smaller than a couple other dwarf planets like Eris and I think 1 or 2 others. So yeah, I know there are a lot of people who famously were upset when Pluto was downgraded, and I think Neil deGrasse Tyson talks about that in his later Cosmos. But at this time, Pluto was still considered a principal planet beyond Neptune.
billions of comets, the family of the Sun, yellow dwarf star surrounded by a system of 9 planets, dozens of moons, thousands of asteroids, and billions of comets, the family of the Sun. Only 4 light hours from Earth is the planet Neptune and its giant satellite Triton. Even in the outskirts of our own solar system, we humans have barely begun our explorations. Only a century ago, we were ignorant even of the existence of the planet Pluto. Its moon, Charon, remained undiscovered until 1978. The rings of Uranus were first detected in 1977. There are new worlds to...
Notice, of course, how he correctly says Uranus, not the way it is said for the sake of pun jokes.
The rings of Uranus were first detected in 1977. There are new worlds to chart even this close to home. Saturn is a giant gas world. If it has a solid surface, it must lie far below the clouds we see. Saturn's majestic rings are made of trillions of orbiting snowballs. We are now only 80 light minutes from home, a mere 1.5 billion kilometers. The largest planet in our solar system is Jupiter. On its dark side, superbolts of lightning illuminate the clouds, as first revealed by the Voyager spacecraft in 1979.
Well, there you go. I'm assuming this must have been shot in '79 then, because either that or they were, extrapolating what would have been seen. But yeah, given that they're suggesting this has been observed by the time he's recording this monologue, I'm guessing this is from '79, not '78, like I said.
Inside the orbit of Jupiter are countless shattered and broken worldlets, the asteroids. These reefs and shoals mark the border of the realm of giant planets. We are now entering the shallows of the solar system. Here there are worlds with thin atmospheres and solid surfaces, Earth-like planets, with landscapes crying out for careful exploration. This world is Mars. In 1976, after a year's voyage, 2 robot explorers from Earth landed on this alien shore. On Mars, there is a volcano as wide as Arizona and almost 3 times the height of Mount Everest. We've named it Mount Olympus. This is a world of wonders. Mars is a planet with ancient river valleys and violent sandstorms driven by winds at half the speed of sound. There is a giant rift in its surface.
Admittedly, hard not to think about Arnold Schwarzenegger struggling for air in the film Total Recall.
Half the speed of sound. There is a giant rift in its surface, 5,000 kilometers long. It's called Valles Marinaris, the Valley of the Mariner spacecraft that came to explore Mars from a nearby world. In this, our first cosmic voyage, We have just begun the reconnaissance of Mars and all those other planets and stars and galaxies. In voyages to come, we will explore them more fully. But now we travel the few remaining light minutes to a blue and cloudy world, third from the sun. The end of our long journey is the world where we began. Our travels allow us to see the Earth anew, as if we came from somewhere else. There are 100 billion galaxies and 1 billion trillion stars. Why should this modest planet be the only inhabited world? To me, it seems far more likely that the cosmos is brimming over with life and intelligence. But so far, every living thing, every conscious being, every civilization we know anything about lived there, on Earth.
And just in case that phrasing billion trillion is confusing, like think of a box with 1 trillion stars, and Sagan's saying there's 1 billion boxes like that, so it's 1 billion trillion stars in the observable universe. And I do believe that estimate has been perhaps updated and slightly expanded given the precision of some of the telescopes that have now been put into space. But either way, we're talking, again, as you said at the beginning, a scale and a scope that is beyond ordinary human comprehension and is difficult for our minds to conceive the immensity of.
Beneath these clouds, the drama of the human species has been unfolding. We have, at last, come home.
Welcome to the planet Earth, a place with blue nitrogen skies, oceans of liquid water, cool forests, soft meadows, a world positively rippling with life. In the cosmic perspective, it is, for the moment, unique. The only world in which we know with certainty that the matter of the cosmos has become alive and aware. There must be many such worlds scattered through space, but our search for them begins here, with the accumulated wisdom of the men and women of our species, acquired at great cost over 1 million years.
So here's where I'm going to get emotional. Basically, people who know me know that Beethoven's Seventh Symphony, and even more specifically the first movement, is one of my favorite pieces ever. And it already was that by the time that I really saw these as an adult. When I was in when I was in high school, I began listening to a lot more classical music, especially as I got out of high school into the early 2000s. And for whatever reason, not only did Beethoven become one of my go-to composers, but this symphony, and specifically one CD recording I had of it, I forget who the conductor, who the orchestra was, but it was one that I just listened to again and again. And the first movement always was very powerful to me. And then a few years later, I would see a J-drama called Nota Me Cantabile, in which the Seventh Symphony of Beethoven features very prominently. So, like, in different aspects of my life, both independently and in relation to two of my favorite things, Cosmos and Nota Me Cantabile, this particular movement is very prominent. So, like, when I hear this, all these things come into my head, and it's just such a well-composed piece. As Beethoven himself once said when asked what one of his favorite compositions that he had written was. So, yeah, this movement will forever be legendary.
The wisdom of the men and women of our species, acquired at great cost over 1 million years.
once a time when our little planet seemed immense, when it was the...
And just as a little teasing or foreshadowing, so many of the shots we're seeing here will be explored, and so many of the implications of what's happening will be explored more specifically and in more detail over the coming episodes.
There was once a time when our little planet seemed immense, when it was the only world we could explore. Its true size was first worked out in a simple and ingenious way by a man who lived here in Egypt in the 3rd century BC.
This tower may have been a communications tower, part of a network running along the North African coast by which signal bonfires were used to communicate messages of state. It also may have been used as a lighthouse, a navigational beacon for sailing ships out there in the Mediterranean Sea. It is about 50 kilometers west of what was once one of the great cities of the world, Alexandria. In Alexandria at that time, there lived a man named Eratosthenes. One of his envious contemporaries called him Beta, the second letter of the Greek alphabet, because he said Eratosthenes was second best in the world in everything. But it seems clear that in many fields, Eratosthenes was alpha. He was an astronomer, historian, geographer, philosopher, poet, theater critic, and mathematician. He was also the chief librarian of the great library of Alexandria. And one day, while reading a papyrus book in the library, he came upon a curious account.
Far to the south, he read, at the frontier outpost of Syene, something notable could be seen on the longest day of the year. On June 21st, the shadows of a temple column or a vertical stick would grow shorter as noon approached. And as the hours crept towards midday, the sun's rays would slither down the sides of a deep well, which on other days would remain in shadow. And then, precisely at noon, columns would cast no shadows, and the sun would shine directly down into the water of the well. At that moment, the sun was exactly overhead.
It was an observation that someone else might easily have ignored. Sticks, shadows, reflections in wells, the position of the sun, simple, everyday matters of what possible importance might they be. But Eratosthenes was a scientist, and his contemplation of these homely matters changed the world, in a way, made the world. Because Eratosthenes had the presence of mind to experiment, to actually ask whether, back here near Alexandria, a stick cast a shadow near noon on June the 21st. And it turns out, sticks do. An overly skeptical person might have said that the report from Syene was in error, but it's an absolutely straightforward observation. Why would anyone lie on such a trivial matter? Eratosthenes asked himself how it could be that at the same moment, a stick in Syene would cast no shadow, and a stick in Alexandria, 800 kilometers to the north, would cast a very definite shadow. Here's a map of ancient Egypt. I've inserted two sticks, or obelisks, one up here in Alexandria and one down here in Syene. Now, if at a certain moment each stick casts no shadow at all, that's perfectly easy to understand, provided the Earth is flat. If the shadow at Syene is at a certain length, and the shadow at Alexandria is the same length,
That also makes sense on a flat Earth. But how could it be, Eratosthenes asked, that at the same instant there was no shadow at Syene and a very substantial shadow at Alexandria? The only answer was that the surface of the Earth is curved. Not only that, but the greater the curvature, the bigger the difference in the lengths of the shadows. The sun is so far away that its rays are parallel when they reach the Earth. Sticks at different angles to the sun's rays will cast shadows at different lengths. For the observed difference in the shadow lengths, the distance between Alexandria and Syene had to be about 7 degrees along the surface of the Earth. By that I mean, if you imagine these sticks extending all the way down to the center of the Earth, they would there intersect at an angle of about 7 degrees. Well, 7 degrees is something like a 50th of the full circumference of the Earth, 360 degrees. Eratosthenes knew the distance between Alexandria and Syene. He knew it was 800 kilometers. Why? Because he hired a man to pace out the entire distance so that he could perform the calculation I'm talking about. Now, 800 kilometers times 50 is 40,000 kilometers. So that must be the circumference of the Earth. That's how far it is to go once around the Earth. That's the right answer. Eratosthenes' only tools were sticks, eyes, feet, and brains. Plus
I don't remember what year it was published. I'm going to assume maybe like 20 years ago now, but somewhere in my collection of books I have a historical, I guess it's not really a biography because it's about more than just Eratosthenes, but it's called Circumference, and it's about him making this discovery and the experiments he did, and as Sagan was saying, paying someone to mark out the distance between Alexandria and Syene. So yeah, you could probably find it on Amazon or somewhere, but there's an interesting book about this called Circumference.
Zest for That's the right answer. Eratosthenes' only tools were sticks, eyes, feet, and brains, plus a zest for experiment. With those tools, he correctly deduced the circumference of the Earth to high precision, with an error of only a few percent. That's pretty good figuring for 2,200 years ago. Then, as now, the Mediterranean was teeming with ships, merchantmen, fishing vessels, naval flotillas, but there were also courageous voyages into the unknown. 400 years before Eratosthenes, Africa was circumnavigated by a Phoenician fleet in the employ of the Egyptian pharaoh Necho. They set sail, probably in boats as frail and open as these, out from the Red Sea, down the east coast of Africa, up into the Atlantic, and then back through the Mediterranean. That epic journey took 3 years, about as long as it takes Voyager to journey from Earth to Saturn. After Eratosthenes, some may have attempted to circumnavigate the Earth, but until the time of Magellan, no one succeeded. What tales of adventure and daring must earlier have been told as sailors and navigators, practical men of the world, gambled their lives on the mathematics of a scientist from ancient Alexandria. Today, Alexandria shows few traces of its ancient glory, of the days when Eratosthenes walked its broad avenues. Over the centuries, waves of conquerors converted its palaces and temples into castles and churches, then into minarets and mosques. The city was chosen to be the capital of his empire by Alexander the Great on a winter's afternoon in 331 BC. A century later, it had become the greatest city of the world. Each successive civilization has left its mark. But what now remains of the marble city of Alexander's dream? Alexandria is still a thriving marketplace, still a crossroads for the peoples of the Near East. But once it was radiant with self-confidence, certain of its power. Can you recapture a vanished epoch from a few broken statues and scraps of ancient manuscripts? In Alexandria, there was an immense library and an associated research institute, and in them worked the finest minds in the ancient world. Of that legendary library, all that survives is this dank and forgotten cellar. It's in the library annex, the Serapeum, which was once a temple, but was later reconsecrated to knowledge. These few moldering shelves, probably once in a basement storage room, are its only physical remains. But this place was once the brain and glory of the greatest city on the planet Earth. If I could travel back into time, this is the place I would visit. The Library of Alexandria at its height 2,000 years ago. Here, in an important sense, began the intellectual adventure which has led us into space. All the knowledge in the ancient world was once within these marble walls. In the Great Hall, there may have been a mural of Alexander with the crook and flail and ceremonial headdress of the pharaohs of ancient Egypt. This library was a citadel of human consciousness, a beacon on our journey to the stars. It was the first true research institute in the history of the world. And what did they study? They studied everything, the entire cosmos. Cosmos is a Greek word for the order of the universe. In a way, it's the opposite of chaos. It implies a deep interconnectedness of all things, the intricate and subtle way that the universe is put together. Genius flourished here. In addition to Eratosthenes, there was the astronomer Hipparchus, who mapped the constellations and established the brightness of the stars. And there was Euclid, who brilliantly systematized geometry, who told his king, who was struggling with some difficult problem in mathematics, that there was no royal road to geometry. There was Dionysius of Thrace, the man who defined the parts of speech, nouns, verbs, so on, who did for language, in a way, what Euclid did for geometry. There was Herophilus, a physiologist who identified the brain rather than the heart as the seat of intelligence. There was Archimedes, the greatest mechanical genius until the time of Leonardo da Vinci. And there was the astronomer Ptolemy, who compiled much of what today is the pseudoscience of astrology. His Earth-centered universe held sway for 1,500 years, showing that intellectual brilliance is no guarantee against being dead wrong. And among
I always love that line because, again, there are people who are very wise and smart and knowledgeable, but who have convictions and propositions in their mind that in the end evidence shows to be in error. So I love that line, that genius is no protection against being dead wrong.
Held sway for 1,500 years, showing that intellectual brilliance is no guarantee against being dead wrong. And among these great men, there was also a great woman. Her name was Hypatia. She was a mathematician and an astronomer.
And shout out to Hypatia. Ultimately, those who follow my Ambient Excursion series will know that some of the mythology I've built up around the different installments of the excursion include a location that is dubbed Hypatia. So yeah, a lot of the concepts and mythology that I use in relation to some of my DJ mixes, the Ambient Excursions in particular, is based off knowledge and history that I learned, at least in large part, through the Cosmos series.
Dead wrong. And among these great men, there was also a great woman. Her name was Hypatia. She was a mathematician and an astronomer, the last light of the library, whose martyrdom is bound up with the destruction of this place 7 centuries after it was founded. Look at this place. The Greek kings of Egypt, who succeeded Alexander, regarded advances in science, literature, and medicine as among the treasures of the empire. For centuries, they generously supported research and scholarship, an enlightenment shared by few heads of state then or now. Off this great hall were 10 large research laboratories. There were fountains and colonnades, botanical gardens, and even a zoo with animals from India and sub-Saharan Africa. There were dissecting rooms and an astronomical observatory. But the treasure of the library, consecrated to the god Serapis, built in the city of Alexander, was its collection of books. The organizers of the library combed all the cultures and languages of the world for books. They sent agents abroad to buy up libraries. Commercial ships docking in Alexandria harbor were searched by the police, not for contraband, but for books. The scrolls were borrowed, copied, and returned to their owners. Until studied, these scrolls were collected in great stacks called books from the ships. Accurate numbers are difficult to come by, but it seems that the library contained at its peak nearly 1 million scrolls. The papyrus reed grows in Egypt. It's the origin of our word for paper. And each of those 1 million volumes which once existed in this library were handwritten on papyrus manuscript scrolls. What happened to all those books? Well, the classical civilization that created them disintegrated. The library itself was destroyed. Only a small fraction of the works survived. And as for the rest, we are left only with pathetic, scattered fragments.
Which, again, anyone who studies ancient history will know, not just in regard to Hellenistic Egypt, but in many other times and places, there are references to books and works of both literature and science that existed, but which there are no copies anymore. People will, talk about the lost films of the 1920s and so on, where we know there were films, we know that they were shot and performed or shown, but then through fires at cinemas and so on, the only copies were lost. And so now we just know they exist and there's no evidence of them. So yeah, when you study ancient history and even more modern history, you run into that the documentary record is almost always incomplete, and in some cases, even bits and even books and other materials that remain are only fragmentary. Like there's a lot of works from, say, Democritus, who we're going to hear about more, that we know exist but we don't have anything from, and the little bits we do have from him are often recounted by later authors, like writing about even more historical figures. So yeah, as a historian, I can tell you it's always one of the struggles, is that the documentary record is always incomplete.
But how tantalizing those remains destroyed. Only a small fraction of the works survived. And as for the rest, we are left only with pathetic, scattered fragments. But how tantalizing those remaining bits and pieces are. For example, we know that there once existed here a book by the astronomer Aristarchus of Samos, who apparently argued that the Earth was one of the planets, that like the other planets, it orbits the sun, and that the stars are enormously far away. All absolutely correct. But we had to wait nearly 2,000 years for these facts to be rediscovered. The astronomy stacks of the Alexandria Library. Hipparchus, Ptolemaeus. Here we are. Aristarchus. This is the book. How I'd love to be able to read this book, to know how Aristarchus figured it out. But it's gone, utterly and forever. If we multiply our sense of loss for this work of Aristarchus by 100,000, we begin to appreciate the grandeur of the achievement of classical civilization and the tragedy of its destruction. We have far surpassed the science known to the ancient world, but there are irreparable gaps in our historical knowledge. Imagine what mysteries of the past could be solved with a borrower's card to this library. For example, we know of a 3-volume history of the world, now lost, written by a Babylonian priest named Berosus. Volume 1 dealt with the interval from the creation of the world to the Great Flood, a period that he took to be 432,000 years, or about 100 times longer than the Old Testament chronology. What wonders were in the books of Berosus. But why have I brought you across 2,000 years to the Library of Alexandria? Because this was when and where we humans first collected seriously and systematically the knowledge of the world. This is the Earth as Eratosthenes knew it, a tiny spherical world afloat in an immensity of space and time. We were at long last beginning to find our true bearings in the cosmos. The scientists of antiquity took the first and most important steps in that direction before their civilization fell apart. But after the Dark Ages, it was by and large the rediscovery of the works of these scholars, done here, that made the Renaissance possible and thereby powerfully influenced our own culture. When in the 15th century Europe was at last ready to awaken from its long sleep, it picked up some of the tools, the books, and the concepts laid down here more than 1,000 years before. By 1600, the long-forgotten ideas of Aristarchus had been rediscovered. Johannes Kepler constructed elaborate models to understand the motion and arrangement of the planets, the clockwork of the heavens. And at night, he dreamt of traveling to the moon. His principal scientific tools were the mathematics of the Alexandrian Library and an unswerving respect for the facts, however disquieting they might be. His story and the story of the scientists who came after him are also part of our voyage. 70 years later, the sun-centered universe of Aristarchus and Copernicus
was widely accepted in the Europe of the Enlightenment. The idea arose that the planets were worlds governed by laws of nature, and scientific speculation turned to the motions of the stars. The clockwork in the heavens was imitated by the watchmakers of Earth. Precise timekeeping permitted great sailing ship voyages of exploration and discovery, which bound up the Earth. This was a time when free inquiry was valued once again. 250 years later, the Earth was all explored. New adventurers now looked to the planets and the stars. The galaxies were recognized as great aggregates of stars, island universes, millions of light years away. In the 1920s, astronomers had begun to measure the speeds of distant galaxies.
What time is it? 7:15. All right, lights out, please.
They found that the galaxies were flying away from one another. To the astonishment of everyone, the entire universe was expanding. We had begun to plumb the true depths of time and space. The long collective enterprise of science has revealed a universe some 15 billion years old, the time since the explosive birth of the cosmos, the Big Bang. The cosmic calendar compresses the local history of the universe into a single year. If the universe began on January 1st, it was not until May that the Milky Way formed. Other planetary systems may have appeared in June, July, and August, but our sun and Earth not until mid-September. Life arose soon after. Everything humans have ever done occurred in that bright speck at the lower right of the cosmic calendar. The Big Bang is at upper left in the first second of January 1st. 15 billion years later is our present time, the last second of December 31st.
Every month is 1.25 billion years long. Each day represents 40 million years. Each second stands for some 500 years of our history, the blinking of an eye in the drama of cosmic time. At this scale, the cosmic calendar is the size of a football field, but all of human history would occupy an area the size of my hand. We're just beginning to trace the long and tortuous path which began with the primeval fireball and led to the condensation of matter, gas, dust, stars, galaxies, and at least in our little nook of the universe, planets and life, intelligence, and inquisitive men and women. We've emerged so recently that the familiar events of our recorded history occupy only the last seconds of the last minute of December 31st. Some critical events for the human species, however, began much earlier, minutes earlier.
So we change our scale from months to minutes. Down here, the first humans made their debut around 10:30 p.m. on December 31st. And with the passing of every cosmic minute, each minute 30,000 years long, we began the arduous journey towards understanding where we live and who we are.
11:46. Only 14 minutes ago, humans have tamed fire. 11:59:20, the evening of the last day of the cosmic year, the 11th hour, the 59th minute, the 20th second. The domestication of plants and animals begins. An application of the human talent for making tools. (11:59:35). Settled agricultural communities evolve into the first cities. We humans appear on the cosmic calendar so recently that our recorded history occupies only the last few seconds of the last minute of December 31st. In the vast ocean of time which this calendar represents, all our memories are confined to this small square. Every person we've ever heard of lived somewhere in there. All those kings and battles, migrations and inventions, wars and loves, everything in the history books happens here in the last 10 seconds of the cosmic calendar.
We on Earth have just awakened to the great oceans of space and time from which we have emerged. We are the legacy of 15 billion years of cosmic evolution. We have a choice. We can enhance life and come to know the universe that made us, or we can squander our 15 billion year heritage in meaningless self-destruction. What happens in the first second of the next cosmic year depends on what we do here and now with our intelligence and our knowledge of the cosmos.
R.I.P. Carl Sagan, I love you, and shout out to Anne and Steven Soder as well, who were involved in the writing of the series. But yes, as I said, there's so much that we see and hear about in that opening episode that we're going to get a lot more detail on in the remaining 12 episodes. Yeah, shout out to Richard J. Wells, who did the, I guess, green screen. I'm not sure exactly how they did that whole Library of Alexandria scene, but that was, like, impressive technology for the late 1970s. Well, there you go, folks. And the collector's edition, which is, again, this was compiled and released years later, so shout out to all these people too. But as I said, we've got 12 more episodes. My plan is to do them roughly on the 25th of each month, so that when we come back around for the very final episode, it'll be on Christmas of next year. Now, there might be a few times along the way where it happens, you know, the 26th, the 24th, something like that. But yeah, my plan will be to do each of them on the 25th of every month. Well, there you go, folks. So, yes, Merry Christmas, Happy Holidays, and indeed, if you enjoyed that, rest assured there are 12 more episodes just as good. So let me know what you think, and I will see you next time. Peace.